Okay, good morning all. Thank you for your patience and thank you for joining today. My name is Gareth Doust. I'm a team lead within our modern data center practice, looking after our on-premise and cloud infrastructure consultants. I'll shortly be passing you over to Serge, a solutions architect within the team, who's broadly experienced. I'm not going to steal his thunder. He'll introduce himself shortly. But just to set the scene, what we want to talk about today, generally just some of the data lifecycle management challenges that we face in the real world, and rather than talking about specific technological solutions, what we're really trying to do is build a little bit about a bit of background around the business challenges that we feel need to be addressed and that we're seeing crop up in some of our customers. And from there on in, we'll talk about some of the solutions we can implement or assist you with. With that in mind, if you do have any questions, please do pop them into the chat. I will keep an eye out while Serge is talking, and if I feel it's appropriate to interject and ask the question at the time, I will. Otherwise, we'll wait till the end of the webinar and clear up any questions there. If we run out of time or there are any questions we're unable to answer today, we will follow up with an email individually to you as well, just to get those all covered off. Thank you very much once again, and over to you, Serge.
Yes, great. Thanks. Thanks, Gareth, for the introduction. So just a little bit about myself. So my name is Serge Musen. I'm a solutions architect with Ultima for the past 4 years. I've got over 20 years of experience in data center and have mostly been specializing in servers, storage, converged and hyper-converged infrastructures. I've been helping customers, lots of customers over the years with designing, implementing, as well as migrating core data center infrastructure in various industries, ranging from banking, insurance, government, petrochemical, energy, and manufacturing. So I also have a particular passion for automation as well. And then, yeah, finally, to round it off, I'm also certified in VMware, Pure Storage, Nimble, and Red Hat. Okay, so let's get into it. Just really short, the agenda of the topics that we're going to be covering today. So first, we're going to be looking at the current challenges with data and data management. And then we're going to be talking about data storage in general, data protection, and data management. So let's start off with the current challenges as we see them. So I wanted to start off with this picture here, depicting sort of the global data sphere. This comes from an IDC and Seagate study called Data Age 2025. And the global data sphere, as they've defined it, basically is comprised of traditional core infrastructure, which consists of dedicated data centers, public, private, and hybrid cloud. And then we also have the edge. The edge is usually physically separated from the core data centers, and the edge is there usually for faster response times and regional coverage. And then we have all of the endpoints that are looking at and creating data. So that can be things such as mobile devices, IoT, sensors, cars, lots of things really. So this is really just to illustrate the huge amount of data, that's being produced or rather within this whole data sphere. So let's talk a little bit about the explosive data growth that we are seeing. So this global data sphere will continue to grow at approximately 20 to 35% annually, according to various analysts, with a predicted 175 zettabytes of storage in 2025. And just, that's obviously a huge amount of data. Just to put it into context, at least a little bit, that is equivalent to about 12 billion 16 terabyte hard drive. So yeah, it's an enormous amount of data. So what we can see at the moment, so obviously we're in 2020 at the moment, we've already have a current size of about 50 zettabytes, and that will grow 3.5 times over the next 5 years. And that is data, that's created by consumer and user behavior that has changed. People demand immediate access, and so data also needs to be made available immediately. So what we're seeing is solutions and data have shifted towards users who in turn generate more data, coupled with an emergence of technologies that enable fast access, such as broadband, which is now typically over 100 gig. And then also on the mobile side, the new 5 gig that is coming in, enabling more and faster access to data. So the growth rate is expected to be higher, specifically for endpoints, with the billions of IoT devices generating lots of real-time data and real-time data collection, and that is expected to consume, that part of it is expected to consume about 90 zettabytes. So that's 51% of the total of the 175 zettabytes by 2025. So the question is, how are we going to rise to the occasion to meet all the demands and that change in user behavior? So let's talk about that a little bit more. So another trend that we see is sort of the shift from the on-premise data center to the cloud. So during that rapid increase of data, the transition from traditional data centers and public cloud is predicted to be at 49% by 2020. So yeah, much more importance or much more data flowing into the public cloud, and the data that's in enterprises is decreasing over time. Due to the operational diversity of data center, edge, and cloud environments, many IT managers choose point solutions on a best-of-breed basis. Whilst that might be a good tactical approach, longer term, it would be preferable to have a consolidated approach to storage management wherever possible. So let's talk about the data management challenge. So data is going to be ranging from relatively simple emails to data that's subject to regulation, such as personally identifiable information, intellectual property, and classified information. So automated enforcement of policies will really be the only way, to manage such large amounts of data that's both, critical and sensitive, and to do that effectively. So analysts are predicting, as we can see here, by 2025 that 75% of all data will require some sort of special storage policies. Storage infrastructure management is a special challenge for many organizations, and research by analysts shows that a lot of organizations use more than one backup and recovery product. And in addition, many have a combination of traditional SAN storage arrays, NAS filers, hyper-converged, object and cloud storage, all backing specific application requirements, and each system is typically managed with its own UI and set of tools. So storage capacity utilization across all sectors of industry is notoriously inefficient. And as such, over-provisioning has really been a common practice when acquiring new storage platforms to compensate for the lack of reliable means to be able to track and forecast storage requirements. Now, over the last number of years, vendors have been addressing that challenge and really helping out customers by improving storage capacity utilization using various storage efficiency technologies. And yeah, the most immediate ones that come to mind are deduplication and compression. And that's in an effort to reduce capital costs outlay and really improving the bound per gigabyte stored ratio. It's estimated that storage efficiency technologies improve utilization by about 50 to 60%. That in turn reduces the cost of data storage by approximately 17% overall. So that's quite significant. There's also been new features that have been introduced that allow organizations to shift some of the data storage to the cloud as well. As the scaling up of traditional storage is no longer the only way really that we see customers expanding their storage footprint to meet the data growth. So then final point is really the increasing stringent data protection requirements. They're becoming more commonplace. So the current best practice target overall is 15 minutes for RPO and about an hour for RTO on average. So just to define, for those who may not be aware, so RPO, when we're talking about RPO, what we mean is a recovery point objective, and that is really how old the data is at the point that we restore it. And then RTO is recovery time objective, and that is how long does it take us to restore that data. So that means there's a market change from just a couple of years ago. And a function of the increasing reliance, really, of business on technology to achieve and retain competitiveness across all industries. And this trend is really expected to drive down to close to or zero RPO and zero RTO over the next few years. So another thing is that analyst research has shown that there's still a significant gap in backup recovery success KPIs. So what we've seen is that the average success rate for backup and recovery jobs is only at around 85%, whereas the specified best practice really aims to be closer to 97%. That is important because an improved backup and storage success rate translates directly to less downtime and data loss. So this is really our view of how we see how data should be stored, protected, and managed. And the focus is with really the user and data consumer at the top there, where dependent on the use case, the appropriate solution may actually encompass multiple technologies that make up an overall solution to meet the business demands. So then the three pillars that we see, data storage, and that really is about workload optimized, potentially composable systems that can span mission critical, general purpose, and secondary storage, as well as big data and AI workloads. That together with cloud data services so that you can embrace the hybrid cloud as well. These can all be bidirectionally connected to improve data mobility so that the data can really flow seamlessly across the lifecycle. And then the data protection. So that's really, the data that is on primary or secondary storage that needs to be protected. And of course, the well-known use case there is to be able to restore data from accidental or potentially malicious deletion. And of course, the disaster recovery use case. Now, data on primary storage that is protected can also be leveraged for dev and test purposes as well. So that's sort of a new use case that we're seeing, that we can leverage the data that we've already duplicated for data protection means that can be leveraged, as I mentioned, for dev and test purposes. And so the final layer there on top, data management. And as part of data management, you should really be looking for storage systems that contain software-driven intelligence within them. That helps with predicting and proactively resolving issues before they occur. These systems can also create a unique workload fingerprint to recognize the unique characteristics of each individual workload across the global installed base of hundreds of thousands devices spanning storage systems, servers, and VM farms that are out there in the field. So those the workload fingerprints combined with global learning should enable the system to drive recommendations to make sure that your application workloads and supporting infrastructure is always optimized and delivering at a predictable speed as well. So cloud management will also bring context awareness and enable a seamless and intelligent data lifecycle management. So just kind of to give an example of what a data platform could be comprised of. It could be comprised of modern block-based all-flash arrays for mission-critical workloads, for instance, and those can be managed from the cloud and provide data services that can span both on-prem and public cloud. So examples of that is, either Pure Storage or Nimble. NetApp is another example there. And that in turn can be coupled with a data protection platform that contains intelligence and easy management, and can cover both data protection, but potentially also copy data management use cases, and as well as providing an API that can be used to automate the environment. And some examples there are products such as Cohesity and Rubrik. Okay, so let's start off with data storage. So why should you be concerned about this? Well, as we've seen, the data is growing at almost exponential amounts, and budgets, on the other hand, are getting cut. So we have to do more with less. However, that growing data does require us to have a platform to be able to store all that data. Then, on the other hand, there's the increasing complexity. So we spoke a little bit about, the hybrid world, hybrid IT. That means multiple sources to protect. So it's no longer just your on-prem storage. You also have to think about what you've got in the cloud. And we still want to be able to be agile for the business, and that means being able to provide capacity fairly quickly, but also providing the right performance for each of the use cases. So there's a bit of a balancing act as we're now living in what's often called the idea economy, where success is defined by the ability to turn ideas very quickly into value, and preferably faster than your competition can do that. So the question is, how do IT departments really balance business demand for operating cost reductions with shrinking IT budgets, whilst at the same time implementing agile and scalable solutions that enable the business to take advantage of that idea economy. So the answer, we believe, can be found in software-defined solutions, but paired with the right strategy and as well as operational processes to support that. So to talk a little bit more about the idea economy, so IT is the business partner for value creation. So IT must be able now to support these two worlds. So on the one hand, we've got the traditional applications that are designed, to support and automate existing business processes such as collaboration, data processing, and analytics, but also supply chain and web infrastructures. And then on the other hand, we have a new breed of applications and services which drive revenue directly and new customer experiences by leveraging mobility, big data, and cloud-native technologies. So IT is really being stretched, to be able to support both the traditional environments as well as the new data-driven environments from cloud apps. So you want to be able to meet that challenge and have an infrastructure that can help you do that. So why software-defined storage? Well, that's really about all these things. So software is intelligent, and commodity hardware is becoming more and more mature. So software-defined storage really gives you an ease to scale up. It's going to be a lot easier to sort of scale up that infrastructure. It also enables flexibility, mobility, and agility. And as I said, commodity hardware is now more mature and definitely enables 24/7 availability. And commodity hardware also means it's going to be cost efficient. And then, the software intelligence means it's going to be simple to manage as the software intelligence does things such as built-in, health check capabilities, for instance. And then this is just to give an example of, the enormous amount of choice that's currently out there, from a storage perspective. So this is called the software-defined 120 club. There's supposedly around 120 different vendors in this space across block, file, hyperconverged, and object storage. So yeah, I guess the question here is, how do you choose from that huge amount of choice that's provided and out there in the market at the moment. So here is a strategy that we believe can help narrow down that choice. So it's really simplifying choice by focusing on the problems that organizations are looking or need to solve, and that we can do that by defining use cases that provide solutions to the problems, and then categorizing the technologies that meet those use cases, and then some technologies that can obviously also span multiple use cases. So it's really a dynamic environment, and technologies and the use cases may change as requirements and the market itself obviously change with it. So talking a little bit about the different use cases that we're seeing. So there's the private cloud, with high performance storage to support VMs on various hypervisor platforms. And containers are now also coming into play, with Kubernetes being fairly popular at the moment. Then there are application file services, so that could be looking at scalable file services for applications storing large quantities of files or requiring very high performance and low latency storage. Then on the other hand, we also have the user file services. So file services for a large community of end users that require rich features such as protection, sync, potentially worm, and maybe cloud services. And then of course we've got data protection storage as well. We've got data center replication that can aid with PR. And then we have archive and bulk storage, and that's really looking at durable, cost-effective storage, potentially providing S3 compatible API for access to the storage, and that can also be useful for archiving and management of data. Then turning our attention, to the storage systems themselves and how we manage them. So there's now a trend in the industry that's called AI ops management, and that is really about providing value from your storage components by correlating data across the stack to provide more insights really into your infrastructure. So some examples of storage that have that are InfoSight with Nimble Storage, and that was really one of the first ones to start doing that. Shortly following that, on from that was Pure Storage as well with Pure One. And we're also seeing this happening now on HCI platforms, and examples there are VxRail, Nutanix, and also SimpliVity is following suit there. So this is really an important capacity that your storage system should really be able to offer. Then looking at some of the platform capabilities that really help with storing those huge amounts of data and doing it in the most cost-effective manner. So as data is being created and or acquired, data obviously will need to be stored. Now, in most cases, that will be on primary storage platforms, such as storage arrays, hyperconverged storage, or maybe NAS filers or file servers. Today, each of these platforms now usually come with some form of storage efficiency technologies that will allow organizations to save on the storage of data. So, as I mentioned earlier, it is estimated that storage efficiency technologies improve utilization by about 50 to 60%, which in turn reduces the cost of data storage by approximately 70% overall. And that can really be considered the first line of defense in combating, data inefficiency. So the storage efficiency ratios that we're typically seeing are, on sort of primary storage platforms are about 5.4 to 5:1 now. And on data protection storage, we see that that is even higher at 20:1 to even 30, as high as 30:1. And so those storage efficiency technologies, that consists of things such as deduplication, compression, pattern matching, and zero reduction. And then I also mentioned here cloud integration. So several storage vendors now offer cloud integration capabilities, and the usual names such as Nimble, Pure Storage, and NetApp that can help, with moving that data off the cloud storage for more effective, cost-effective storage management. So let's move on to the sort of the next pillar, which is it's data protection, and why that is important. So again, spiraling costs with the huge amounts of data that we need to protect that is being created on the primary storage platforms. Also, increasing complexity. We talked about hybrid IT and the multiple sources, so that definitely concerns data protection. As I mentioned, we need to be able to protect the storage that we've got on-prem as well as that we have in the cloud. So we also saw that the data availability requirements are increasing. The RTO and RPO, that's sort of driving down, and we need to be able to respond faster to storage requests as well to make the data available faster. And when there's a disaster, we also need to be able to bring up the environment fast. Then, there's really the danger of a lack of data management strategy that can lead to an inability to define proper processes and operational procedures, and that can lead to tactical short-term decision making, which then in turn leads to increased cost due to business complexity and downtime. So this is really just talking about the data flow that we see in the data sphere that we talked about earlier. So how much data the organization stores does not only include the data held on primary or secondary storage platforms, it also includes the data that is held for the purpose of data protection, which in essence obviously is a duplication of data, but with the specific objective to be able to restore data in case of a calamity. Now, in order to keep the costs from spiraling out of control, you need to make smart decisions about which data to back up in the first place. And secondly, you need to ensure that your backup software can store that data in the most efficient way, taking up as little storage space as possible. And then thirdly, you need to ensure that you can restore the data as fast as possible in case of an accidental deletion, but also in the case of disaster recovery, as we mentioned. But perhaps most important of all, you need to have thought through how long you need to keep each type of data. So as an example, many of you will have heard or maybe experienced the case where a manager comes in and decides he needs to have access to data of an employee that's left 3 months ago. So how are you going to be able to do that? So that really points to the need of having effective policies in place. So coming back to the RTO and RPO, so we mentioned here that the current best practice target for RTO and RPO is 60 minutes for RTO and 15 minutes for 15 minutes for RPO and 1 hour for RTO. So there's a cost associated with driving down RTO and RPO to near zero or zero. Whilst there certainly is a trend to achieve that, this is happening across the board. And when the TCO required to do this brings it down in reach of most organizations. When it can happen cost effectively. So a zero RPO RTO is currently relatively expensive, with expensive synchronous replication technologies that are typically only found in sort of higher end storage today. But over time that may change. Also, just wanted to make a note that we typically, with our customers, we typically see that the RPO is a day, and the RTO is anything from 4 hours to a day. So there's really no sort of one size fits all here. So it's really about the RTO versus the storage cost, and there is a trade-off between being able to restore data from backup in a timely fashion and being able to store backup data at the lowest possible price point. And a simple example to illustrate that, data can be restored very rapidly from either a storage snapshot on the primary storage array or potentially an instant VM recovery from secondary storage platform. However, if that data needs to be restored from tape or maybe a dedupe backup appliance, that is going to take significantly longer. So another thing to think about is really the data that is stored in the cloud. And so what we mean by data that's stored in the cloud, so that could vary, from data that is stored in a storage account or potentially Azure files, or data that is stored, on VMs, on IaaS VMs, but also data that is stored on PaaS platforms. The examples given here are Azure SQL, but it could also be Amazon RDS. But it could also be, on websites, data that you've got there. Then that can also span SaaS applications. So, the most commonly known one is Microsoft 365. But we also more and more see things such as Salesforce for CRM. And then for HR, we've got products such as Workday and Monday that are becoming more and more prevalent. So the important point there is that obviously you can outsource, the management of the platform, but you still have to carry the responsibility, and that also means the responsibility to be able to restore data if anything were to happen to these platforms. And you want to be able to keep management as light touch as possible, and you might need different solutions for each of these. There might not be a single solution that can cover everything. And just as a final sort of point to show how complicated this can be, some customers are starting to have multi-cloud strategies as well. So that may mean that your product, may not only need to support whatever's in Azure, but also potentially in AWS and Google Cloud as well. Another point that I wanted to sort of raise awareness of, no doubt you will have heard of this, but it's the GDPR regulation. And so that is, an important one that we always hear about is the right to be forgotten. But the GDPR regulation actually consists of 99 articles in total. And it's sort of predicated around one or more of 7 core principles. And those are lawfulness, fairness, and transparency, purpose limitation, data minimization, accuracy, storage limitation, integrity and confidentiality, as well as accountability. And so what I try to illustrate here is sort of the balance that we need to find between what's within Article 32. And Article 32 is about the security of data processing, and it makes it clear that data processing is more than ensuring the confidentiality of the data, but it's also ensuring that the entire data management strategy is comprehensive. And it includes structural initiatives, such as documenting processes and enabling organizational awareness. And that also includes ensuring that the technical strategy incorporates resiliency, availability, and integrity. So that's on the one hand. And then on the other hand, Article 17 is about the right to erasure. And so it's about finding that balance. So Article 17 seems at direct odds with Article 32 at first glance. Article 32 being about the security of processing and potentially, immutable backups, whilst under Article 17, personal data must be erased without undue delay. With many organizations, they're setting a target of doing that within 30 days. So if your organization keeps backups for 10 to 30 days, your data will potentially age out on the backups within a reasonable amount of time. But if you need to keep backups for longer, for example, 6 months or longer, then you will have many months where you potentially hold personal data that a subject has asked to be erased. And that could potentially be against the EU data subject's wishes. Now, there are some mitigating reasons that, if your reasons fall within the requirements of Article 32, for instance. So the reason that we mentioned this is that, non-compliant businesses can be fined up to 20 million euros, or 4% of the worldwide annual revenue, whichever is higher. So there are quite significant amounts of fines if you can't be compliant. So some examples of technology that can help make you compliant. So at present, some technologies are available to meet the GDPR obligations. An example of that is the redaction feature that exists within Commvault. And so using the right products can help with that, where it's, otherwise it's nearly impossible to exercise, redaction on backup tapes. And so you may need to consider, are tapes still the right relevant solution to use, or should I implement a product that can enforce redaction upon restore of data? That's also a possibility. And there are products out there that can help with that. And so it's all about, being able to notify the EU data subject of all steps and precautions taken in your right to be forgotten confirmation. And it will not only let the EU data subjects know that your company has honored their request, but also that it's thought through the process and made a conscious decision to go above and beyond to maintain data transparency. So then just quickly on archiving. So many organizations, depending on applicable regulations of the industries that they operate in, will be required to maintain data for a set period of time. So in some instances, the organization is required to prove that that data cannot be tampered with, and thus it will need to be stored immutable. So regardless of whether an organization needs to comply with regulations, it can make good business sense to archive data. So in most cases, the low-hanging fruit is in unstructured data, but depending on the industry, unstructured data can also make up a significant portion of the total data landscape. And 80% is not unusual in some sectors that we've seen. So in that case, you really need automated archiving. to ensure that data is stored on the most cost-effective platform. So finally, sorry, not finally, just wanted to raise also awareness around malware protection. And that's just to say, that the average cost of being able to recover from that is now sort of estimated at about £62,000 per incident. So it's important, that your infrastructure, your data, your storage management infrastructure is designed for operational survival. And in the pie chart, so the donut chart that we see there, we can see, that 71% of the targets for malware and ransomware specifically are actually small and medium businesses, and about 29% is businesses in the middle market. So some of the design considerations there are about that you can take are doing things such as air gapping, OS hardening, and potentially also immutable storage. Now, finally, on data protection, I also wanted to make a point about copy data management. By doing data protection, we obviously make a copy of data for the purpose of being able to restore in the event of a calamity. But we also make copies of data for the purpose of dev and test. So really the point that we want to bring across here is that you need ideally to have a system in place that can help you do this. And those systems typically comprise of a central catalog, a policy engine, and reporting capability. And when we think about reporting, it's really the ability to provide reports that allow you to answer queries such as, did the ERP database replicate successfully to the DR side, or maybe the question was, is there the copy of the SQL database for dev team application consistent, or potentially, how many copies do I have of the financial database in my storage environment? So the value for organizations is in being in control of your copies, which gives you the ability, to expire and delete copies that are no longer needed easily, and that in turn, saves on storage cost by decreasing the total storage amount. And this capability can now be found, in modern data protection platforms. And examples there are, again, platforms such as Cohesity and Rubrik. So moving on really to the final sort of pillar about data management. And again, why I should be concerned? Starting off with the similar theme, the unprecedented sprawl of data across organizations, including the rapid expansion and growth of unstructured data, leading to higher storage costs. But I also need to take these other points here into consideration, such as security, breach risk, non-compliance with regulatory requirements, as we've seen, but potentially also missed opportunities, and that's the potential for missed opportunities caused by an inability to leverage the strategic value of data through business intelligence or analytics. And a lot of organizations are now, working to mitigate that risk. It's complex, if not impossible, to manage, support, and maintain, larger systems without really having proper data management in place. And not being able to protect data in situ properly also adds, more manual work, increasing time, cost, and inaccuracy of data, they could potentially lead to fines for non-compliance, as we've seen. And then a final point here to consider is the risk also in dark data. And we're going to talk about that in a minute. And the dark data may potentially contain incriminating evidence in the case of litigation. So data governance is really a data management concept concerning capability that ensures that an organization that enables an organization to ensure that high data quality exists throughout the complete life cycle of the data. And data controls are implemented that support business objectives. And so the key focus areas of data governance include the ones that I've listed here. So availability, usability, consistency, data integrity, and data security. So another important point there is data governance requirements are not always the same for all types of data. Now, another important point is dark data. So this is often called the databerg, which is an analogy for iceberg. And Gartner defines dark data as information assets an organization collects, processes, and stores during regular business activities, but generally fail to use for other purposes. For example, analytics, as we mentioned, business relationships, or even direct monetization. So, yeah, the issue with that really is, as you can see, the business critical data is really only 14% of the total data that we store. And we have about 32% of ROT data, which is an acronym for redundant and obsolete and trivial data. And then there's 54% of what's termed as dark data, data that we just don't know exactly what it is and what value it has for the organization. Then turning specifically, our attention to ROT data, so the redundant and obsolete and trivial data. So businesses need to hold, obviously, some of old data that they don't access very often, and that might be for audits, as we've seen, or regulatory compliance, or the challenge that it will have business value later on. So ROT does not refer to that type of data, but it's it really refers to, as the acronym says, redundant, obsolete, and trivial data. So that's data that we can really get rid of. So mostly ROT doesn't just cost extra money to store and protect, but it also can inhibit organizations in the 5 ways that I've mentioned here. So additional infrastructure and support costs, causing lag in decision making, increased risk of data breaches, as we've seen, and increased liability. So how to eliminate ROT? So here are just sort of 5 things to think about. So if at all possible, consider ways to keep from collecting that data in the first place. If you have a business reason to collect some low value data, then make sure that it's being stored and potentially archived on low cost storage. Rely upon a central data repository, and a central data repository will dramatically reduce redundancy. It also prevents each user from needing to maintain their information, and in turn, it should reduce the chance of introducing errors and obsolescence. So use technology here to help you out. Good data management systems can help root out bad, redundant, and old information. And then it's also important to set the right policies and communicate them across the enterprise. So data classification and as data enters the data maintenance and subsequent stages, you should be able to classify data. And data can be classified, here's just an example of how data can be classified. And the data that is found both, in structured and unstructured data. The challenge is really mostly in unstructured data. So data classification can be, geographical, chronological, quantitative, and qualitative. So why do we classify data in the first place? Well, first of all, it's about lighting up the dark data, so we know the kind of data that we have, and that allows us to act upon the data by introducing automated policies that can state, where the data needs to be kept. So high priority data potentially on high performance storage, while low priority data should really be on low cost storage. And also, for how long do we keep that data, and when can we get rid of that data? The other things are minimizing risk of legal exposure and identifying potentially, unusual usage reporting. That all, in turn can lead to less costs for the business as well. So finally, just wanted to raise Ediscovery. We've mentioned it a little bit, but it refers to the discovery in legal proceedings, such as litigation, maybe government investigations as well, where data is sought in electronic format. It's subject, obviously, to rules of civil procedure and agreed upon processes, and it often involving review for privilege and relevance of the data before the data is turned over to the requesting party. So you really want to have a system in place that allows you to spot, the data that is relevant for a specific case, and being able to reproduce that data in the format that the requesting party accepts. And it's also about, that data, when you need to store it, where do you store it? It can be on-prem or it can be in the cloud. But you need to be able to find really the best storage platform that allow you to store that for the lowest cost possible. So I'm conscious that we sort of run out of time, but I just wanted to leave you with some final thoughts. So we've covered a lot of ground in this presentation, and I thank those that have sort of hung on, and just leave you with these final thoughts. So we recently, worked for a customer in the insurance industry that was struggling with the spiraling cost issue, and we did a storage optimization engagement for them, and we were able to deliver a 30% reduction in storage footprint. And we did that by analyzing their complete storage landscape and identifying inefficiencies in storage tiering, as well as suboptimal data protection policies. And it's important to note that we even spotted, further opportunities for cost reductions that could be had by employing methods that we discussed in the webinar today. And that can help drive down the storage footprint even further by, up to 50%. So the other thing it's important to note is that there's no sort of one size fits all. All companies have different objectives, cultural heritage and infrastructure setups that require unique approaches to achieve the goal of reducing storage cost. And then finally, we'd love to talk to you about this more, and specifically how we can help you with this. So contact your salesperson if you want to know more about this. And that's about it. I don't know if there are any questions left to be answered.
Thank you, Serge. No, there's nothing in the chat at the moment. Obviously, give people a last opportunity now to raise a hand or ask any questions if there are. But I think the key takeaways, as you've said here, are data management really does involve numerous interconnected challenges, and depending on the nature of the business in question, the solutions can look very different from one organization to the next. So what we're really doing here is just presenting a bit of a picture of the challenges that can be faced. Not all challenges will be faced by all organizations. Some will be more relevant than others. But absolutely key for me is understanding your data and eliminating unnecessary data, because that in itself is going to reduce costs significantly, and will have a knock-on, because if you reduce your storage, you reduce the amount you're having to archive, you reduce the amount you're having to back up, and you also mitigate any litigation risk as well. So thank you for that. In the absence of any questions, please do enjoy the rest of your day, and if you think of anything later, obviously feel free to contact your account manager or any of our team. Thank you very much.
Thank you.